Hey everybody, thank you for coming. For those of you who've seen our technology before, there's going to be something new to talk about today, quite a few new things. For those of you who aren't, we're going to try to get you up to speed on what the capabilities of this technology and the developments we've made are over the last year. So let's get right into it. First, quick snapshot of the company and what our mission is. Our mission is to make printed electronics and integrated electronics and the packaging of them easier, more complete, more reliable, and improve the throughput abilities there. One of the major ways we're different in doing so is that we've put in our own full prototype manufacturing facility in our location in New Jersey, which gives us the ability to do product development and prototype development with our materials and other materials into a finished packaged device, which we can prove out a process, scale it up even into full-scale manufacturing on an SMT line, and then transfer that into our customers. And that's kind of been how we've grown our business, the model for our business up until now, along with selling conductive inks and some of our other conductive products, is to help companies integrate innovative new technologies like ours. So this is an overview. We've got a brand new facility we just moved into, 11,000 square feet with some very unique capabilities. We can do some very fine pitch placement with a Finetech Lambda piece of equipment for semiconductor packaging. We've got a full SMT line that can replicate what major contract manufacturers might have in place for component placement, and we can do high-speed printing. For those of you not familiar with Z-Tac, this is basically what Z-Tac is. It is an anisotropic conductive epoxy that does not require extreme heat or any pressure to functionalize. The major feature here and the patent IP that we have is on both the material formulation, which is ferromagnetic particles that are dispersed into a resin system and then processed by way of a rare earth magnetic carrier pallet. So we're not using electromagnets, we're using standard rare earth magnets that we've specially engineered and designed that can give us very good uniform column formation of these ferromagnetic particles, give us low resistance in the range of 8 to 20 milliohms centimeter at fine pitch down to 100 microns or 50 micron pad space and size. One of the other unique properties of this material is we can offer you far higher bond strength than typical conductive adhesives because we're using very low solids content of the functional particles. Because we're only creating these Z-axis particle column alignments, our loading is on the opposite end of what a typical ECA or even a conductive ink might be. You're going to be looking at somewhere between 60 and 90% loading. We're about 15 to 20% loading. The rest of that is the polymer epoxy in the case of our thermally cured version, or a different, more innovative technology in the case of our UV version that we're introducing today. And what we have is the ability to form these columns very rapidly and quickly. We'll show you a video that gives you a sense of that, to give you a very reliable, mechanically high bond strength bond attachment at low resistance and fine pitch, and the ability to do this without coplanarity, and that's another important concept here. We don't need coplanarity between the component and the substrate because our columns will form until they hit something. So we have the unique ability to attach three-dimensional surfaces and substrates. Gives you a highly bendable, highly flexible product. Doesn't require pressure to functionalize. We can cure at very low temperatures and very high temperatures, and it easily integrates into an SMT line. And one of the hurdles that we had when the early days of forming this technology was showing people the results and showing them finished parts and what we could do, which was very innovative. But the assumption was made that this must take some sort of complicated or expensive equipment. I encourage you to go by our booth after the show or after the talk today and see the expensive equipment. Andrew is in our booth. He's the inventor and our CTO, and he's bonding components with UV Z-Tech in our booth by hand with a little piece of metal that's about the size of a notebook. That's the complicated, expensive equipment it takes to process the technology. So this is what you're going to see, or this is what you would see if you had a highly magnified X-ray camera looking at Z-Tac. This is a cross-sectional view of the material, and as soon as it comes out of pick and place and goes onto our magnetic pallet, this is how quickly these columns form. So in about 4 seconds, just made contact when you see the particles move. 4 seconds later, we've got columns. Within about 8 seconds, we've got a fully functioning column formation. The material is cured, locked into place, and we've got Z-axis interconnection without pressure or high heat. On the right, you're looking at a standard component, a resistor component that's been bonded with Z-Tac. As I mentioned, fully scalable on existing SMT lines. The only difference in the case of our process is the particle alignment takes place by placing those components after you've put the Z-Tac down, put it through pick and place the components, comes out, goes on